is another statement. Yeah, I could have written this only. Or what should I write? X squared is less than 0 implies x squared is greater than 0. X squared is less than 0 implies x squared is less than 0. Now I should mention that in this x is any real number, or x is a real number. Otherwise it does not make sense. Otherwise these statements are ill-defined. Why are they ill-defined when I do not consider x to be a real number? That is somewhat advanced, okay? Advanced for school level. So we will come to that later. So now x is a real number. Now consider these implications. X, if x is equal to 2, then x squared is equal to 4. Okay, by the way, this implication, there are many ways of writing this. We can write this as like this, or x implies y, or if x then y, or y is true if x is true. Or there is one more way of writing, although this is somewhat confusing. X is true only if y is true. So you can write like this, or this, or this. Others, although they are the same thing, the last one takes quite some effort to see why it is the same thing as this. For example, if x is true, then y is true. Okay, I would suggest to not think about this much. If you like, you can think about it, but it's more likely that you will get confused. So just for the sake of completeness, I have included it, but more commonly, these are the ways we write this. If then, if something is true, then something else is true. Okay. Now, in this case, we see that here the hypothesis is true. There is nothing wrong about it. X can be 2. If that is the case, then x squared is 4, which is also true. So that means this implication is true. Here x is equal to 2, that is true. But then x squared is equal to 9, that is not true. When x is 2, x squared is not 9. So true hypothesis, false implication, that gives us, a false conclusion that gives us false implication. This cannot be the case. The last two, however, are true. You see, in the first one of the last two, in both of them, the hypotheses are false. These, although they are the same, this is false. We know from elementary properties of real numbers that the square of a real number is always non-negative. It is never negative or greater than 0. This cannot be the case. In fact, at one point we will prove this. We are going to prove these things. But now we consider them as given, and so here the